In this video, we're going to look at the intersection of lines and circles. Now, we've previously learned about the intersection of lines and curves, and the intersection of lines and circles are very similar. They can intersect at 2 points, 1 point, and that would be a tangent, or no points at all. And like before, we can use substitution to work out how many times a line and a circle touch. And we can use a discriminant for that as well, but we can also use substitution to find the points of contact if they exist. So, example 1 then, we want to find the points where the line with equation y equals 3x intersects the circle with equation x squared plus y squared equals 20. So, like I said before, we will use substitution for this so that we can solve for either the x or the y ordinates, and then we can find the other ordinate to get the point of contact. So you can see here that we've got the equation of our circle, and the equation of our line is y equals 3x. Now, within the equation of our circle, we also have a y. So instead of y, we're going to put 3x. So we've got x squared plus 3x all squared equals 20. That gives us x squared plus 9x squared, which is 10x squared equals 20. Dividing throughout by 10 gives us x squared equals 2. And then square rooting both sides of the equation gives us x equals positive and negative root 2. Now this obviously corresponds to these points, root 2 something and negative root 2 something. So in order to get our y ordinates, we need to go back to one of our original equations and substitute in. And obviously the easiest equation to use here would be the y equals 3x. So if we take that, the equation of the line, and substitute firstly x equals root 2, we will get positive 3 root 2, and when we put in x equals negative root 2, we obviously get negative 3 root 2. And that gives us the following points: root 2, 3 root 2, and negative root 2, negative 3 root 2. And we'll just have a quick look at what that might look like on the graph. Okay, so you can see in red there we've got the circle with equation x squared plus y squared equals 20. And you can see that we've got the line y equals 3x, and you can see those 2 points of intersection that we have calculated. So just now would be a good time to pause the video and copy this example down in your notes before coming back for examples 2 and 3. Okay, welcome back folks. So second example then, we want to find the points where the line with equation y equals 2x plus 6 and the circle with equation x squared plus y squared plus 2x plus 2y minus 8 equals 0 intersect. So we can see this time we've been given the circle, and it's in the general form of the equation of a circle. Again, we can see that the line that we've got is y equals 2x plus 6. And we have y's within the equation of the circle. So we're going to substitute in there. Instead of y, we'll have 2x plus 6. So that gives us x squared plus 2x plus 6 all squared plus 2x plus 2 times 2x plus 6 minus 8 equals 0. Now we need to expand our brackets. So that will give us this. So you can see the square of 2x plus 6 gives us 4x squared plus 24x plus 36. And this bracket here, 2 times 2x plus 6 gives us 4x plus 12. Now, if we collect like terms, so you can see we've got 5x squared here. For our x terms, we've got 24x, a 2x and a 4x, so altogether that gives us 30x. And then for our constants, we've got 36, 12 and negative 8. So altogether that gives us 40. So we've now got a quadratic equation, 5x squared plus 30x plus 40 equals 0. Now you'll notice that there's a common factor of 5 here, so I'm going to divide throughout by 5, leaving me with x squared plus 6x plus 8 equals 40. And that just makes the process of factorising just now that bit easier, because it's now a unitary coefficient of the x squared term. So factorising here is x plus 4 multiplied by x plus 2 equals 0. And that corresponds to, that gives us if we solve that, equal to 0, we've got x equals negative 4 and x equals negative 2. And as I was going to say, that corresponds to the points negative 4 something and negative 2 something. Now we need to find those y ordinates though, these missing points at the moment. So I'm going to go back to one of my original equations, and the equation of the straight line would be much easier to use than the equation of the circle. So y equals 2x plus 6, and I'm going to start off with when x is negative 4. So when x is negative 4, y is negative 2, and when x is negative 2, y is positive 2. So you can see we've now got our 2 points, negative 4, negative 2, and negative 2, 2. And we'll just have a look at what that looks like on the graph. So you can see there we've got our 2 points where the line with equation y equals 2x plus 6 intersects the circle with this equation here. So just now, folks, would be another good time to pause the video, copy this down in your notes, and come back for example 3. Okay, welcome back, folks, and we'll look at example 3 now. So we want to show that the line x minus 3y equals 5 is a tangent to the circle with equation x squared plus y squared minus 6x plus 8y plus 15 equals 0, and find the point of contact. So obviously we want to substitute something in place of x and y. That's what we've been trying to do so far. And that's how we find points of intersection. Now we've got this equation here for the line x minus 3y equals 5, and you can see that at the moment it's not any use to us because we've not got x equals or y equals, but we can easily change that so that one of these is the subject of that formula. So I'm going to add my 3y to both sides of this equation, and that will give me x equals 5 plus 3y. And that then allows me to substitute that into the equation of the circle, and it'll leave me with one variable. At the moment I've got x and y, and I can't do anything with that. But if I substitute 5 plus 3y in instead of x, then I will only have the one variable, which is y. So substituting will give me 5 plus 3y all squared plus y squared minus 6 times 5 plus 3y plus 8y plus 15 equals 0. Now if I expand those brackets, you can see the expansion of the first one, 5 plus 3y all squared, gives me 25 plus 30y plus 9y squared. I've still got my y squared here. Expanding this bracket, negative 6 times 5 plus 3y gives me negative 30 minus 18y. And I've still got my 8y and my 15 at the end, and that is all equal to 0. Now collecting like terms gives me 10y squared plus 20y plus 10 equals 0. And hopefully you've now noticed that there's a common factor here of 10. And if I divide throughout by 10, I will be left with y squared plus 2y plus 1 equals 0. And again, if we can divide throughout by that common factor, then I would do it because it makes factorising a little bit easier. So factorising y squared plus 2y plus 1 will give me y plus 1 and y plus 1. So that's y plus 1 all squared equals 0. And think about the first part of the question that we were asked. We were asked to show that the line x minus 3y equals 5 is a tangent to the circle. Now remember, if we are showing tangency, it means that we have a repeated root, which we do here. We've got this repeated root and that implies tangency. So we've shown that the line is a tangent, so we now need to find the point of contact. So we can solve y plus 1 all squared equals 0 for y. That will give us y equals negative 1. So that corresponds to the point something negative 1. So to find that something, we can go back to the equation of our line. Again, it's easier to use that. And we've got x equals 5 plus 3y. Or you could use x minus 3y equals 5. It doesn't matter which form of that equation you use, you'll get the same answer. And we substitute in y equals negative 1. And that gives us x equals 2. So we can see there that we've got the point 2, negative 1. And that's our point of contact. Now, at this stage, we could have used the discriminant to show that it was a tangent if we wanted. So when we have the quadratic equation, y squared plus 2y plus 1, or alternatively the 10y squared plus 20y plus 10 equals 0, you can use the discriminant. So b squared minus 4ac, that will give us 2 squared minus 4 times 1 times 1, and you can see that that gives us 0. And we know that when the discriminant is equal to 0, it means that we've got equal roots, and in this case it means that therefore we have a tangent. Now if we just look at that diagram, you can see there that the line is a tangent to the circle. So before the screen goes blank, I would pause the video, copy this down in your notes jotter. I would be trying the assigned exercise for today, and then I would be going and familiarising yourself with a lot of the tricky circle questions which exist in higher maths. So I would definitely be going and doing a lot of past papers. We're now at the end of this topic, but it's really good for you to get as much practice on the circle questions as possible, because some of the questions can be quite abstract and they require a little bit of thinking outside the box. So it's definitely worth going to practice all of that.